Okay, number 11, determine whether the mean value theorem can be applied. So again, I wrote down what the mean value theorem says. It has to be continuous on the interval and differentiable on the interval. Well, my function is x cubed, so we know that's continuous, and we know that that has a derivative from 0 to 1. Alright, so we're going to do exactly what it says. We're going to find this part first. So I'm going to find f of 1 minus f of 0 over 1 minus 0. Okay, so let's see what that is. When I plug 1 in, I just get 1 minus 0 when I plug 0 in, over 1 minus 0, so that's 1. We like that. That's easy. Now we're going to find the derivative. So now we're doing this part. So the derivative is 3x squared. Now it says to set those two things equal to each other. So 3x squared equals 1. Divide by 3. Oops. So I get x squared equals 1/3. I'm going to solve by taking the square root. So I get x equals plus or minus the square root of 1/3. Now here's the deal. We only care about the answer that falls within our interval. So I do not have to worry about the negative one. So my answer is the square root of 1/3. And that's my answer. Okay, number 12. The data in the table below gives selected values for the velocity of a particle moving along the x-axis. The velocity is a differentiable function of time t. Okay, so here are my times, here's my velocity. So it says at time t equals 2, so here's 2, is the particle moving to the left or to the right, and explain your answer. Okay, well we should remember when we were doing particle motion that a particle is moving to the left when the velocity is negative, and it's moving to the right when the velocity is positive. So at 2 seconds or 2 minutes, my velocity is -3, so I know it is moving to the left because my velocity was negative, or less than 0. And that's it. 13. Find any relative extrema, or maxes and mins, from the interval from -8, right here, to 10. So if they've given me my derivative, that's what I'm looking at. I'm looking at f prime, and they want me to find the maxes and mins of my f of x. So if I'm looking at the derivative, I know I have maxes and mins where it crosses the x-axis. Okay, because when my derivative is 0, that's where I have critical points. Okay, so I have critical points here, here, and here, because that's where my derivative is 0. So now I just have to figure out at those points, is it a max or a min? Well, do you see at this point right here, and that's, let's see, what is that? That is -6. So when x equals -6, my derivative went from negative to positive because it was below the x-axis. Now it's above the x-axis. So if it goes from negative to positive, I have a min because f prime of x went from negative to positive. So at x equals 1, right here, it went from positive to negative. So I have a max because my derivative went from positive to negative. And then again, my derivative went from negative to positive at, what is that, 1, 2, 3, 4, 5? 1, 2, 3, that is 5, right? So I have a min at x equals -6, and at x equals 5. I'll just put it like that. I have a min because f prime of x went from negative to positive. Okay, so that's it on that one. Oh, so I'll end that and I'll start this one on the next video. Well, I'll go ahead and finish it. Let's do number 1. Find the maximum volume of a rectangular box that can be made by cutting equal squares from the corners of an 8-inch by 15-inch rectangular sheet by folding the sides up. Find the dimensions of the box of largest volume. So we should know by now that volume is length times width times my height. Okay, here's my box. This is just like the problems we've done in class. I'm cutting out these squares. I know it's not drawn like this. So I'm going to say this side's 15. This is 8. I'm taking out this X amount from each side. So now this side is no longer 15. It's going to be 15 minus 2x. And this side is no longer 8. It's going to be 8 minus 2x. Okay, so my volume is this side, 15 minus 2x, times this side, 8 minus 2x, times my height, which is x. Okay, so I'm going to say 15 minus 2x. I'm distributing my x, so that's 8x minus 2x squared. So now I'm going to go ahead and FOIL this out. So 15 times 8, 120x. 15 times 2x squared, that's minus 30x. Why do I have a, squared. So 15 times 8 is this, 15 times 2 is this. Negative 2x times 8x, that's minus 16x squared. And negative 2x times negative 2x squared is plus 4x cubed. So I'm just going to kind of fix that a little bit. Volume equals 4x cubed minus 46x squared plus 120x. Now I'm going to find the derivative of that. So v prime equals 12x squared minus 46 times 2, 92x plus 120. So I need to set this equal to 0 and solve. Since it's a quadratic equation, I can solve that lots of ways. We can solve it by factoring, we can solve it by graphing, see where it crosses the x-axis, we can solve by the quadratic formula. I would use my ACT formula, the quadratic formula, and when I plug that in, 12, negative 92, and 120, I'm going to get two answers. I get x equals 6 and x equals 1.667. Okay? Well, if I chose 6, okay, and plugged it in right here, 2 times 6 is 12, 8 minus 12, I get a negative side. So I automatically know that 6 cannot be my answer. So I know that my x is 1.667. That's actually my height. I'm going to find this side by saying 15 minus 2 times 1.667. So 15 minus 2 times 1.667 is 11.667, or 6. That's that side. And then 8 minus 2, I'm finding this side now, 1.667. It's going to be 8 minus 2 times 1.667, 4.666. So that are the dimensions of my box. Okay, however you want to write that. There's my height, there's my length and width. And I need inches on those. Okay, so problems 2 through 5 will be on the next video.